And what is difference between these formulas? In power function, variable, we have in the base. And in the exponential function, we have variable in the power. Okay, my question is, what will be integral of function e to power 7 dx? Any idea?
E power 7 plus c.
So you think it's e to power 7 plus c. Okay, any other idea? Okay, I have other question. What will be derivative of 5 to power 4 dx?
Well, isn't it same as like constant?
5 to power 4.
It will be 0, isn't it? Will not it?
No, don't confuse. 0 is derivative of constant function.
Power of 4 is
0 is derivative.
Yeah.
constant, right?
But
X and
when
X to power 5 over 5.
yeah.
when into integral sign, we have constant function. For example, 5 dx.
625.
5 dx. What is integral 5 dx?
5x. No.
Yes, 5x, absolutely right. 5x, because if we will take derivative from the 5x, it will be 5.
Yeah.
So we or other ways to move out 5 constant from the integral across integral sign, and we have integral dx.
Mm.
And integral dx, it's x to power x plus c. Okay, let's go back to our problem. What will be derivative of this? What will be integral? This integral.
625x.
25x plus c.
C, yeah.
Okay. Now let's go back to this integral.
7x plus c.
And we should take into account that e to power 7, this is constant function. E is constant, and of course, e to power 7, it also will be constant function. So we can move out e to power 7 across integral sign, and we have let's see these formulas.
E to power 7 x plus c.
Yes, absolutely, Luca, you are right. So it's not correct, but we can, I will write down here, we can move out e to power 7 because it's constant. So don't confuse in future e to power x and e to power 5, 7 or some constant number. It's constant and it's integral dx plus c. And we know integral dx it's x, so we have e to power 7x plus c.
Mm, yeah.
Any questions about it? Okay, let's erase. I hope you have a notebook or some paper with pen to write down these formulas. As for this example, here we have constant, and this constant in the integrand function, it's not 4 but 1 over 4. So 1 over 4 we can move out across integral sign, 1/4, and in the integral we have e to power x minus 3x dx. And now this integral we can split by two integrals. It's integral e to power x dx minus, and at the same time I can move out 3 and write down 3x dx. Do you agree?
Yes.
It seems to me there is one mistake.
The parentheses. Like
What?
we should use parentheses, like 1/4 is for both.
Yes, 1/4. 1/4, it's common factor. So I should multiply by 1/4 both integrals. And now I think it's clear. It's 1/4, and in the parentheses we have first integral, it's e to power x minus 3 times x square over 2 by power function plus c. Any questions about it? So 50 is the same. And I think you will be able to find this integral. 50 is the same. Any other question about homework? Okay.
I had like 50, but I can make it like by myself later.
Okay.
Thank you.
I believe you can it. Okay. Any other question? For example, 48. What about 48? About this problem, there was a very good question from Georgi Odishvili. And Georgi's question was that square root from the x square, it's absolute value of x. Not x, but absolute value of x. Do you agree with Georgi?
Yes. It was.
Yes, but how can we find? I will write down this example. Integral 2/square root x minus square root x square dx. So square root from the x square, it's absolute value of x. And Georgi's question was, how can we integrate absolute value? Do you have any idea how to solve this issue? Solution is here, and solution is that here we have square root. And because we have this square root, it implies that x must be positive. And that's why we don't need to take in the absolute value x, because absolute value of x, it will be just x, because from this first expression square root, it implies that x is positive. Okay. Now today we will continue integration, and we will do today more complicated integrals. And first of all, let's recall what is differential of function. So for today's topic, what we need? First of all, we need basic formulas, what we did, basic integrals, what we did in the previous class. And second, what we need, I will write down now. This is how to find differential of function. For example, we have a function fx equals x squared. Differential of function is denoted by d, and we can write dx squared. And dx squared, or differential of function, it equals derivative of function multiply by dx. dx is called differential of x. And now we can find it. Derivative of x squared is 2 times x, and it's 2x times dx. So I can write down now formula dfx differential of function, it equals derivative of this function times dx. Okay, let's give other example. For example, we have d5x. Any idea what is d5x?
5dx.
Maybe, let's check. So it's derivative of 5x times dx. And derivative of 5x, it's 5. So it's going to be 5 dx. Okay, let's give other example. For example, we have a function fx equals e to power x, 2 times e to power x. Let's find what is dfx. I can write down dfx, or I can write down d 2 times e to power x. So it's 2 times e to power x derivative
Multiplied by dx.
multiplied by dx. And now we need just to find derivative of 2 times e to power x. And what is this derivative, 2 times e to power x?
Is not it the same? 2 times e to power x.
Yes, I agree. I agree. It will be the same because 2 is constant and we can move out of derivative, and derivative of e to power x, it's again e to power x. So it's 2 times e to power x. Okay. Let's give a next example. For example, we need to find d square root x. And formula is the same. Formula is its derivative of function, and derivative of this function, it means derivative of square root x times dx, it equals Do you remember? It was my recommendation to remember this derivative. But if you don't remember it in your mind, you can use power rule like square root x, it's x to power 1 over 2. But if you remember derivative, it's better. It's 1 over 2 times square root x dx. Any questions? Okay, let me to continue. And for example, now fx equals ln x. What is d ln x? Any idea what is d ln x? It's again derivative of ln x by dx. And what is the derivative of ln x?
1 over x.
It's 1 over x. It's 1 over x.
1.
1 over x times dx. Okay. Now my question is now, for example, I have expression x times dx. What do you think? Is this equality correct? What I will write down now, dx square.
Yes.
I think
Is it true?
maybe. I think it's not because dx is different and x is different.
Okay, let's check, okay? And how can we check it? We can find dx square. And if I will find dx square, it's x square, derivative of x square, times dx. And it's going to be 2x dx.
So it's not.
So it looks they are not equal. They are not equal, but maybe is there easy way to make they equal?
Divide by 2.
Yes, yes, absolutely. I will write down here 1 over 2. Now it's correct. Any questions? Okay, let me to continue. Okay, what do you think? If I will write down e to power x dx equals d e to power x, are they equal?
Yeah, they are.
Yeah.
Yes.
Yes, I agree. They are equal. They are equal because derivative of e to power x, it's again e to power x. Okay. It was exams to prepare to integrate more complicated integrals than we did last week. And let's start by example. Let's start by example. For example, we have a function integral 2x plus 1 to power 3 dx. Do you have any idea how to solve this integral, how to find this integral?
We should do the derivative of the first part.
No, it's not derivative.
Yeah, but
Integral. So we should find function whose derivative is this function.
Can we mark it with other?
yeah, that's
What
possible.
you mean to denote? Denote it by t. Maybe it's a good idea to denote it by okay. Let's denote 2x plus 1. 2x plus 1. Let's denote 2x plus 1. Let's denote, for example, by t. Now, I know now definitely that in this original integral, if this is, let's denote it by e, our integral, and I know now definitely that 2x plus 1 I will replace by t. But question is, what about dx? There will appear two variables, but I don't need two variables. We need to have one variable and simple expression. Any idea how can I substitute this dx? What can I do?
Find the x from this equation and then input it to the.
So you think to solve this, to solve for x,
Yeah,
and
Then
then find dx.
yeah.
I think it's good idea. Let's solve for x, and for x from this equation is going to be 1/2 times t minus 1/2. Is everyone agree with this? Okay. Now I will find dx, and dx I will find as differential of function. It's 1/2 times t minus 1 derivative multiplied by dt. Do you remember derivative of function? It's no, differential of function. It's derivative of function multiplied by dt.
1/2 should not here.
Yes. Derivative of this expression is going to be 1 over 2 because derivative of 1 is 0 because 1 is constant. And here we have 1 over times 2t, and derivative of this function is 1 over 2 multiplied by dt. So now I know now definitely that 2 in the original integral, 2x plus 1, I will replace by t, and dx I will replace with this expression. So let's continue and write down e integral. It's integral 2x plus 1 cube. It means t cube times 1 over times dt. And now I will move out constant 1 over 2 integral t cube dt. And what is integral of t cube?
T power 4 over 4.
Yeah, yes, absolutely. T to power 4 times 4 plus c. Now I can multiply 1 over 2 by 4, and I will have t to power 4 over 8 plus c. But I did not finish yet. Now I will now to replace this new variable t, I will replace by this 2x plus 1 plus t. Okay, let's erase one row. Let's erase one row and continue it. It equals 2x plus 1 2 power 3 over 8 plus c.
Power 3 or 4.
Oh, sorry, 4. Thank you. Any questions? Any questions? Now I want to show other way how to find this integral. And you can choose what is more convenient and more easy for you. And other way is integral the same. Let's write down the same integral. 2x plus 1 to power 3 dx, it equals. And now let me to write down integral 2x plus 1 to power 3 d 2x plus 1. What do you think? Is it true what I wrote down? True, I mean equality. Are they indeed equal?
We should check, I guess.
Okay, please check. Please check and tell me, are they equal? It would be good if they are equal.
Yeah,
because-
yeah, they are. They are.
Are they equal?
I
No, they aren't.
Maybe we need some coefficient.
We should multiply by x. X over 2. No.
Take again, please. Maybe we need some coefficient. Coefficient, I mean some constant number in front of integral to make equal.
Yeah, we need to divide by 2.
We need to, who are you? We need to divide by, we need to divide by 2.
2.
Or I can write down here 1 over 2. Now, if I will check, I should find derivative of 2x plus 1. Derivative of 2x plus 1 is 2 times dx. And this 2 will be divided by this coefficient 2, and these two expressions, they are really equal. Now let's continue. And now I can use formula for integration of power function, because here in the differential and here I have the same expression, and I can imagine that it's t. And by this imagination, and you know, imagination is sometimes more important than knowledge. And it's going to be 2x plus 1 to power 4 divided by 4. It equals 2x plus 1, 4 divided by 8. So this is more, this is shortest way, but you can use previous way, which is more convenient for you. If any questions, ask now. If no questions, I will continue and we will do similar examples. Let's.
Why were they equal? The first two.
First two, why this first two equal? You mean this, Luca?
Yeah, dx and the 2x plus 1.
Dx and d2x plus 1, they are not equal. Let's write down d2x plus 1 and dx. They are not equal, Luca. But if I will write down here coefficient in front of dx, if I will write down 2, or if I will write down here 1 over x, they will be equal. You can check, because, okay, I will explain in details. So I have here this 1 over 2, this 1 over 2, I will rewrite here 1 over 2, multiply. What is d2x plus 1? It's derivative of 2x plus 1 multiplied by dx. This equals derivative of 2x plus 1. It's just 2. And 2 times 1 over 2 is 1. So I have here dx.
Oh, yes.
Do you agree?
Yes.
Okay. Next example will be similar, and you can use both ways. Integral 3x plus 1 2 power 10 dx. Which way did you like? First or second?
Second one is easy.
What is it? What is easy?
Second one.
Second one, yes, it's shortest way. But it's not always possible. It's not always possible. And problem is that, for example, for derivatives, we have many formulas. We have a formula for product, for derivative of product of function. We have formula derivative of quotient of functions, but unfortunately for integrals, we have no such formulas. And that's why we need to use different techniques to evaluate integrals. And by the way, it's not always possible to find integral. Okay, now let's solve. Let's first of all choose way. Which way we want to use it. Which way? Second one or first?
Second one, I think.
Okay, second one. Let's second one. Okay, I will write down it equals integral 3x plus 1 2 power 10 d 3x plus 1. But now let's check. Is it true? Are they equal?
Oh, do we need to divide it?
1/3.
Yeah.
1/3 here, coefficient. Yes, absolutely. We need 1/3 because this differential d 3x plus 1, it equals 3 times dx. 3 times dx. And to get the original integral, equal integral of original integral, we need to divide it by 1/3. Is it clear for everyone? Okay, and now let's continue. It equals 1/3 3x plus 1 2 power 11 divided by 11 plus c. And now we can multiply 3 and 11, and it will be our final answer. Oh, today our Zoom works very good. I think they give unlimited time. And thanks, Zoom. Maybe good idea to take break for 10 minutes and then continue.
Very good idea.
Okay, okay. Okay, let's take break and after 10 minutes. Don't late.